All right. Well, good morning, folks. I'm sorry, good afternoon. Let's go ahead and let's get started with where we left off yesterday. And we were talking about how we can solve these kinematic problems involving an object that's in motion, and we would be able then to use the kinematic equations that we talked about yesterday and what we learned so far up to this point in order to solve for the problems such as this one yesterday, which we did. Okay. And so essentially what we're doing here, folks, is we have to analyze the problem first, identify the aspects of motion, that is, what are the parts of the how this object moves, okay, that we can identify that's given to us, and then what we're solving for. So doing these kinematic problems is a very straightforward, systematic way, and we should make sure that we have a straightforward, systematic way that we can use to approach solving these problems here. Again, there are just basically three equations that we will use that will allow us to solve for all of these kinematic problems. And I pointed out to you yesterday that it's probably in your best interest to make sure that you memorize these equations. I know that for some of us, myself included, memorization is not my strong suit, but yet sometimes it's worth the effort to memorize these equations or memorize certain things because it just makes solving problems a little bit faster. Okay? In this day and age where we have the internet, you would probably ask yourself, why do we need to memorize anything? Again, my answer to that then is that that sometimes it's fairly cumbersome to try to get your phone or get out a computer and try to find a particular fact that we need to solve for a problem. If we have it memorized, if you have that particular fact memorized, it just makes solving the problem much faster, makes it much smoother. And so these equations here, these kinematic equations, if you have them memorized, it makes solving these problems here faster. It makes it run more smoothly. And so with that said, then I think initially have these problems set to the side, have these equations set to the side so that you can refer to them. But the more you work out these problems, these equations, just you memorize them just by using. Okay, so yes, you should memorize them. But like I said, I think memorizing them would be pretty straightforward as long as you just make sure you do enough of these problems that when you practice them, you'll remember them just through practice. Okay. All right. So what we need to do then is what I'd like to do is just quickly go over a couple of these problems here and practice the procedures that you would use in order to solve for these problems. And then we're going to work out a few more problems, and then we got to go ahead and get started with the free fall problems today. Okay. All right. So what you should do first and foremost, and just make sure you have these problems. We've worked these problems out before yesterday, so just make sure you have your sheet out there, your worksheet out there from yesterday. Okay, and then just compare what you did. Okay. All right. So the first thing you want to do is make sure you identify what you are given. Okay. So let's go ahead. Then we are given this value here in this problem. Okay. So if you take a look at this problem here, you should be able to recognize that this is a velocity. Okay, so this is a velocity that we're given, and whether it's the initial or final velocity, we'll answer that in just a moment, but we do know that this is a velocity. Okay? All right, second thing is you take a look at this particular value here. So that this particular measurement, this particular description here is a description of velocity. We have the magnitude and we have the units for velocity here. And how do we know that these are units for velocity? It's length over time. Okay. All right, the next one we have here is 3.5, and the units here are meters per second squared. And so here we are given an acceleration. Okay, so right now we are given a velocity. We have a velocity, we have an acceleration. Okay, and then finally, then we are given this last number here. Okay, and if you notice from the unit here, we are given a time. Okay. So what we've done then is we've gone through the problem and identified all of the measured values here. And then how do we know? Just look for the numbers, folks. Look for the numbers, look and use the unit to help you identify what you've been given. Okay, so we've been given a velocity, we've been given acceleration, we've been given a time. Okay, what we're asked to solve for then, and this is what we have here, we're asked to solve for a velocity. So in this problem then, we are asked to solve for a velocity. Okay? We are given a velocity here, so this must be then the initial velocity, and we are asked to find then the final velocity here. Okay? So what we've done then is we've gone through this problem, identified all of the values that are given to us, and then we are asked, and then we are identifying the value that we are solving for. Okay? And at this point, then, what you want to do then is either you have it memorized or you have this written on the side on a flashcard, I'm sorry, an index card or a piece of paper. Have the equations written down here so that you can go ahead and quickly reference them. And again, it's a matter of quick reference here. Okay? And decide then which of the kinematic equations you would need in order to solve for the particular problem. Okay? And you can use that by identifying which ones you need. Okay, so we have then 3 that we've gone over so far. Okay, so make sure you have these written down. You'll come across one more as you move forward in physics. Okay? And so the next, so once you've finished identifying what you're given and identifying what you're solving for, go ahead then and you will look at the kinematic equations here and decide which one of these kinematic equations will allow you to solve for your unknown, given everything else that you had here. Okay, so we're solving for V final here. And so if you notice here, the equation number 2 does not have V final in it. This is constant velocity here. Okay, so it's neither V final nor V initial. It's one of the velocities. Okay? And so we don't have this here, but we do have V final in the first equation and in the third equation. Okay? So we have one of these 2 equations should get us the final velocity. Okay? And so now what you have to do is you take a look at the values that are given to you. So we're given V initial here, we're given acceleration, and we're given time. And so if you take a look at the third equation here, we have V initial, we have acceleration, but we need displacement. And we have no reference to displacement in our problem here. And so number 3 here would not be able to give us V final because we were missing this variable right here. And so therefore, the first equation here would give us V final, okay? Because we have V initial here, we have acceleration here, and we have time reference right here. Okay, so that's how we would go about solving for this particular problem. Okay, so we did that yesterday. Those were the steps that we used to solve for these problems yesterday. Okay, and we did the same thing. Okay, and let me go ahead and go on with this particular problem here. Okay, so what you want to do then is let's go ahead and do this one more time. Okay, let's identify. Okay, so we were given this value here. Based on the unit here, we recognize that this is a velocity. Okay, moving on then, we have this value right here that's given to us. Okay? And they also tell us that it's acceleration, so we know that this is an acceleration. Okay? And then finally here, we have this value here, which is a displacement that's given to us. Okay. All right, and so with that said, then hopefully you recognize it. And what they're asking you for here is how fast. Okay, so again, what they're asking to solve for is V final. Okay, so we've gone through and we've analyzed essentially. We've analyzed this particular problem, and we've looked for what we're given. And then we're identifying what we are solving for, and based on that, hopefully you have the equations written out. You'll see then that the equation we would need to solve for V final here is this one, which has V initial. And so this is our V initial, and we're solving for V final. We were given V initial here. We have the acceleration given to us here, and we have the displacement given to us right here. And so we would use the third of those kinematic equations that I listed for you on the previous slide to solve for this problem. Okay. All right. So let me go ahead then, and let's go ahead and let's take a look then at the steps. And essentially, this lists for you what we have just done. And so the homework for tonight, so make sure you take a look at it. The homework for tonight is going to give you more practice with graphing acceleration, but I will try to post these kinematic practice problems for you by this afternoon, and that way you'll have them to work with. But make sure you understand then that these are the steps that you'll follow. Okay, so it's a very systematic way, but I would not memorize these steps. I would use that memory space to memorize the equations, but make sure you understand that these are the steps. And I just wanted to highlight that for you here, that when you work out these problems, it's going to be basically a step-like procedure. Okay, so where you start out, let's draw the diagram. I've always suggested you draw the diagram. Based on that, if you need to, pick coordinate system. You want to make sure you labeled all of the quantities that are given to you, and make sure you convert. Make sure you convert so all the units are the same. Okay. Then what you want to do is make sure you choose the appropriate kinematic equation, rearrange to solve for what is unknown, okay, and then go ahead and solve for it. Okay. Now, we won't have to worry about this, but on occasion, I'm sorry, you will have to consider this when you move on to take physics. For a few of you, and for those of you who have taken physics or you've already known this here, that you may have to combine two equations together in order to solve for your unknown. Okay. All right, so what I would like you to do then is have this slide out in front of you. If you need to pause the screen, pause the video, and go ahead and print up the slider to have it, then go ahead and do so. But make sure you have this here initially to kind of follow the procedures, but I'm going to highlight each step for you as we work through these problems. Okay, so let's go ahead. Let's take a look at this first one here. Okay, and let's work this one out together. Let's go ahead and first of all, let's start out by identifying what's given to us. Okay, and then go from there, figure out how to solve for this problem. Okay. All right. First of all, we have this. Okay. Hopefully, everyone recognizes at this point then that this is an acceleration. They tell us that it's an acceleration here, but we have acceleration. We were given acceleration. Okay. You're given this right here. Okay. This must be then displacement. Okay. So we're given acceleration. We're given displacement. We're asked to solve for a velocity here, and as we've done this before, this is going to be your final velocity that you're solving for. The problem then is, and then let's go ahead and write down the equations that we're going to use. Okay, so the equations we're going to use, V final, okay, is equal to V initial plus acceleration times time. Second equation then is displacement is equal to V, constant velocity, times time, plus 1/2 acceleration time squared. Okay, and then the last one then is going to be V final squared is equal to V initial squared plus 2 times acceleration displacement. Okay. All right. So right now we want to solve for V final. Okay. So again, that won't, equation number 2 won't do it for us. Okay. But if you take a look at this, we have equation number 1 and equation number 3. Okay. So let's take a look at what we have here. So for equation number 1, we need V initial. We don't have that. For equation number 3, we need V initial. We don't have that either. Or do we have it, but they give it to us in a different way? And the answer there is yes, we do have it. They tell us the car starts from rest. Rest meaning that the object, the car is not moving. And if it's not moving, it has a velocity of 0 meters per second. So it does give us the initial velocity. It just doesn't give us a number and a unit, but it describes it for us. Okay, so make sure you keep in mind then that there's sometimes they will give you a description of the velocity. Either it comes to a stop, it starts from the stop, it comes to a rest, or it starts from rest, and you have to be able to use that information to describe then that the velocity at that particular moment in time, whether it's at the initial point or the final point, the velocity is 0. All right. So with that said, then we have enough information now to see then that we're going to use equation number 3 to solve for this one because we have displacement here. Okay. All right. So with that said, then let's go ahead and I want to go ahead and let's solve for this problem. Okay. All right. So let's go ahead and let's start out. I'm going to draw the picture, and I always advise folks to always draw the picture to get a understanding here. So here's our car, mass M. Okay. It's moving in the positive x direction. Okay. So again, we have the positive x direction here, negative on this side. Okay. And so it's moving in the positive x direction. Okay. We were told then that the I'm sorry, let me go back here really quickly. I just want to, whoops, sorry, 500 feet. Okay, I'm sorry. Okay, so we have then the acceleration is, we're told that we said we identified that it's 5 meters per second squared. Okay, we are told then that it moves a distance, a total distance of 100 feet. Okay, and then we are finally told then that the initial velocity here is 0 meters per second, and we are trying to find the final. Okay, all right, and we agreed then that the equation we're going to use, then is V final squared equal to V initial squared plus 2a delta x, okay, because that's going to give us what we need. Okay, so we've drawn the picture, we've labeled with everything we know and what we're solving for, okay, and then make sure, remember, before we continue on with this, we're going to make sure then that all the units are correct, okay, and so if they're not, then we have to do the conversion. If we notice here, though, we can't continue quite yet because this unit here is in feet, and it's not the same as the length units that are described here in acceleration and the velocity, so we have to go ahead and do our conversion. Okay, so 100 feet. Let's go ahead and do the conversion. Okay, and so the relationship, the conversion factor here is going to be about 0.305 meters per feet. Okay, so we'll go ahead and put that in. So the relationship here is for every 1 foot, that's equivalent to 0.305 meters. Okay, all right. So we're going to use this, and again, this here. You find you reference that. Don't memorize these. Okay, so that's why I hate using the empirical system, because the conversion is not as straightforward. But we have this. I just took this off of the internet. Okay, so it's going to be 0.305 meters for every 1 foot. Okay, that'll allow us to cancel that out, and so therefore then this is going to be equivalent to 30.5 meters. Okay. All right, so 100 feet, 30.5 meters, that's what we're going to use here. So let's go ahead then. Now we can solve for the equation. We're going to solve for V final. This gives us V final squared, and so we have to take the square root of both sides. We'll go ahead and do that. This is going to be V initial squared plus 2A delta X. Okay. All right, so let's go ahead and plug in those values. V initial then is going to be 0 meters per second. And we want to make sure we remember to square that, even though it ends up being 0 times 2. Acceleration here is 5, and we were told that it's in the positive direction, 5 meters per second squared. Okay. And so make sure you keep in mind, if the acceleration is positive and the velocity is also positive, remember it's moving in the positive direction, we see then that the car will be speeding up. Okay, so our final answer here has to be greater than 0 meters per second. Okay. All right, and so with that said, then we're not plugging in 100 here. Remember, this is not the value we're going to use. We're going to use this value here, the converted value of 30.5 meters. Okay, so go ahead and plug those values into your calculator. Make sure you do the take the square root of your final answer. Again, make sure you follow the correct order of operation, and then you should end up here with an answer that is 17.5 meters per second. Okay, if you didn't get that, but you set up the problem correctly, in all likelihood you entered the numbers incorrectly into your calculator. Okay, so at that point then, make sure you, if that is the case, make sure you come by and see me, folks, and get help with your calculator, or get help with how we would solve for this particular problem right here. Okay, all right, very good. Let me go ahead then and ask you to work out a problem here, folks. Let's do number 11 in your problem set here. Okay, let's do number 11 in your problem set. Go ahead, take about 5 minutes to work this one, 5 minutes to work this problem out, and then we'll work this out together. Okay. This time though, I'm just going to go ahead and get straight to, and I'm going to draw the picture. Okay, and then we'll label it from there. Okay, so take about 5 minutes to work out this problem, and let's go ahead and see what you come up with. Okay. All right. Let's go ahead then, and let's go ahead and let's take a look at the problem here. Okay, so let's start out. Draw the picture. Okay, so we have then our object, bicycle here, okay, moving in the positive x direction again, moving in the positive towards the right, negative towards the left. Okay. All right, so we are told then that the object moves for a time interval, so we are given the time interval of 4.5 seconds. So it moves for a total of 4.5 seconds, and it undergoes, in this time period, undergoes a displacement of 19 meters. Okay, so 19 meters. We are told that at the end of this 19 meters in 4.5 seconds, its final velocity is 7.5 meters per second. Okay, and so what they're asking us to solve for in this case then is the initial velocity. So they're asking us to find the initial velocity here. Okay, all right. So let's go ahead and let's list the equations that we need again. So I'm going to go ahead and list it for you here. V final is equal to V initial plus A times T, or delta X is equal to V times T plus 1/2 AT squared, or V final squared is equal to V initial squared plus 2A delta X. Okay. All right, so with that said, then which one of these three equations here, which one of these three equations will give us V initial? Well, we have V initial here. we have v initial in again, so we won't use the middle one here because this gives us v initial. Okay? But this one here, we need acceleration to work this one out. Okay? And um, and so we also need, and I'm running a little low on time here. We also need to find the velocity, the acceleration here as well. So the question here I want to ask you then is that, and I want to give you some time to work this one out. Okay, how did you get that acceleration? Okay, so if we have this here, which one of these would you need to solve for it? Okay, so let me ask you to consider this really quickly because this is a bit more challenging, and this is an example of a problem where you have to combine together equations. Or folks, how would you get that acceleration in order to solve for this one? Okay, all right. So let's go ahead then. And we eliminated this one first. And so I'm running low on time here. What I want you to do then is try to find the acceleration using this. Okay, find the acceleration using this first. Okay, and then from there, can you use that acceleration and to find the initial velocity? Okay, so go ahead and get that done. Okay, so see how many of you got that. Okay, and so the hint that I'm gonna give you here then, and we'll finish working out this problem tomorrow, that you need to make sure you get the acceleration using this particular equation here, the one that we actually eliminated to start out with, because that one will give us acceleration. To find the final velocity using the first or the third equation, we need the acceleration, and we don't have that here. Okay. All right. So with that said, go ahead and give this problem another try, okay, and then we will set it up for you here. Okay. And then we'll work out this problem tomorrow. Okay. All right. Very good, folks. I will see you tomorrow, and we'll continue with this problem at that point. Okay. Have a good day.